Hey, how's it going, guys? I just got a nice email from somebody saying they were a bit stumped on numbers 17 and 18 from your problem 5-6 day one problem set, which of course talks about proportional lengths. And the basic proportionality theorem is really where you're getting a bunch of problems in your problem set. You're also getting the corollary of the basic proportionality theorem a little bit in the classroom exercises. Anyways, 17, 18, less than straightforward here. Part of the reason why this is less than straightforward is that in your directions it says, hey, copy the table and fill in as many spaces as possible. Okay, so that's sort of infers the fact that not the fact, but infers the possibility that not all these will get filled in, right? There's probably going to be some ones that are going to be impossible to find. And I think that's going to be true in at least one of these here. So let's check it out. It says it may help to draw a new sketch for each exercise and label the lengths as you find them. Well, I already have that set up. I highly recommend that you do that too because, hey, these are B-level problems, okay? B-level problems start getting a bit harder. And as we've seen so far this year, some B-level problems are pretty darn tough, approaching sort of C-level, really tough type of categorization. So anyways, number 16 wasn't too bad. Maybe we can talk about that one at the end. Number 17 is where the question started with, was how the heck do you do a problem like this? Well, really, you're only given two, right? You're only given two dimensions here. You're given this, NP is 6, and AP is 16. Okay, so one thing that really jumps out to me if I'm going to solve a problem like this is that I can use segment addition postulate to verify that AN's got to be 10. There we go. That's easy. I can put that in. There's 10 right there because 10 plus 6 is 16, okay? What that tells me here, and here's kind of an important thing. What that tells me here is that actually tells me the scale factor, right? Scale factor from this top triangle, which is length 10 here, to the large triangle itself, which on the right side, its corresponding side in terms of its similarity, is 16, okay? So here, our scale factor is 10 over 16. Or, right, if I were to reduce that, 10 over 16 divided both by 2, I would get 5 over 8. This is in a 5 to 8 ratio. So what that means is that over here, okay, over here, AR, for instance, I know that AR, let's let that be 5x. Okay, AR is 5x right here. That means that, maybe I'll do this with a different color, AT would represent 8x here, okay? Because remember, similar triangles have side lengths, corresponding side lengths that are in proportion. Here, we have the small triangle here is length 10 here. The large triangle here is length 16, So it's in a 10 to 16 ratio or 5 to 8 ratio. So here I'm sort of defining a variable and it's sort of just gathering more intelligence to see if like there's possibly a way I can figure this one out here, okay? This is 5x right here. That's 8x right here. So question, actually, can I create an expression for this, for RT? Probably doing too much work on this one, but it's going to help us on number 18. That's why I'm doing this right now. So I can come up with an expression for RT. Well, yeah, if this is in a 5 to 8 ratio here, then this is going to have to be in a 3 to 8 ratio down here. Look at this, 3 to 8 ratio. Check it out here. The same thing's going to hold here for this leg of this trapezoid to the longer side of the triangle. This is in a 6 to 16 ratio. Divide both by 2, right? That's 3. And divide the 16 by 2, that's 8. That's 3 to 8 ratio. 3 to 8 ratio, okay? So I marked it up like this. What about this bottom here, right? What about the bottoms here? Well, this here, okay, RN right here is also going to be in a 5, I'll put it 5y, 5 to 8 ratio with this bottom here, okay? Why? This is the one that I had trouble seeing in high school. I still remember this being like, I keep making mistakes in these problems here, but it's because this here is the top triangle, okay? So here we have the top triangle, right? Our top triangle, okay, we can think about that as 5z, let's call it here. And everything else, all the sides of our large triangle, okay, would be, right, we would be in a 5 for the yellow to 8 ratio for the orange, 5 for the yellow to 8 ratio for the orange, or 10 to 16 as we know that is over here. And then finally, yellow to orange here, right? This because this is a corresponding side of similar triangles here. This RN to TP would still be in that 5 to 8 ratio. Okay, so I'm just putting variables here because we don't know. We know they're in a 5 to 8 ratio, but do we know exactly how long they are? And the answer is no, okay? No for this one here. So all we know, right, all we can deduce from this diagram right here is that this is simply going to be in a 5 to 8 ratio. This is going to be a 3 to 8 ratio. This is going to be a 3 to 5 ratio or a 5 to 3 ratio, right? We can sort of establish the ratios right here, but we don't know any of these exact dimension lengths, right? We don't know what AR is. We don't know what RT is. We don't know what AT is. You need to know at least one, okay? You know the ratios, but you don't know the exact lengths. So you can't actually solve for what X is here. Solve for like what AR's got to measure, what RT's got to measure, what AT is going to measure. So here I'm just going to put NA for all these. Not applicable. I can't figure it out. No solution for that one here. What about this one here? RN to TP. Well, do we know either RN or TP? We know they're at a 5 to 8 ratio, but a lot of things are in 5 to 8 ratios, right? For the number 5, like this could be 5 potentially, it could be 8. This actually looks like 10, side length of 10. Is that 10 and 18? Well, no, we don't know for sure because perhaps this is 6. Right? Not perhaps, it could be 6, right? But what is this? Does this look isosceles up top here? No, it doesn't. This looks like it's maybe a little bit longer than that. So perhaps this is 11 and not 10, right? 11 here. And then 11 to, it's not going to be 16, it'd be like 17 or something like that. So you could estimate it, but you don't know for sure, okay? Are we estimating this here? No, we're deducing things. We're not making inferences and guessing in this situation here. So for both of these, we can't find them, okay? So that was probably why I got emailed that question is because yep, the only thing we can figure out is what AN equals, okay? And that was just from the segment addition postulate. Longest answer ever for just figuring out, or longest explanation ever for just figuring out that this has got to be 10. All right, let's check out 18 here. Because this, I think this one we might be able to figure it out, but I want to use some of the principles that I'm talking about in 17 to help you guys through this one right here. Check it out here. Guys, for this one here, can we actually figure out the scale factor right away? Okay, in this one, we couldn't figure it out right away because we were giving this a 6. It's a 16, and then these aren't corresponding sides of similar triangles, right? This is the side of a trapezoid. That's a side of a triangle here. So I needed to do segment addition postulate to figure out this is 10 here. This is in a 10 to 16 ratio. Let's look at this one down here. Can I actually figure out the scale factor? This is just one way to do these problems, right? It's not the only way to do it. Can I figure out the scale factor from the top triangle to the triangle that it's similar to, right? Because triangle ARN is similar to triangle ATP. So that means RN and TP correspond. What's the scale factor? Well, the scale factor is going to be 30 over 40. Or if I were to reduce that fraction, it would be 3 over 4. Okay? Again, this is an entire side of a triangle. This is an entire side of a triangle. So they're going to have that consistent scale factor here. Let's get the other parts here because that's maybe a little bit harder, right? Easy thing was maybe, well, maybe just missed this and had trouble filling out the rest. But now that you know it's 3 to 4, let's get it. Small triangle. So here, I would recommend doing a problem like this. Small triangle to large triangle. Just remember that, okay? Because we're not going to just like purely do the basic proportionality theorem in this one here. There's just not enough information to do that here. So we're not going to do 18 over this equals that over that. All right, that's true too, but we don't know what AN is. We don't know what NP is. We don't know what RT is. So we're not going to do 18 over this. AN over NP. That doesn't help us. We're going to deduce it a different way, okay? So first of all, this is 18 right here, okay? This is 18 right here. We know that this 18, this distance right here, okay? This is going to be in a 3 to 4 ratio with that distance right there, okay, with what that's going to be. So what I'm going to do is I'm going to call this, 3 to 4 ratio. What's the easiest way to kind of explain this here? Well, I guess I would just set up small to large. Yeah, I would probably set a proportion to solve this one here. So this is going to be 3 to 4 ratio here. Let's make this one X, okay, 18 to X here. So that's in a 3 to 4 ratio, okay, equals 18 over X. I don't really know if there's a better way to explain that. God, I'm trying to think if there's a better way to explain that. I don't know if I do. But here, right, we want to figure out, well, if this is 18, that's going to have to be 24 here because that would be in a 3 to 4 ratio, right? God, I'm struggling with the way to actually properly explain this a little bit better. Yeah, I got nothing for you, I guess. Okay, small triangle to large triangle, I guess this is the best I can do. This here, reminders, right? The yellow guy here, small triangle, corresponds to the large guy here, the orange triangle, what we have down here. So this simply is just in a 3 to 4 ratio. So I'm going to do 3 over 4 equals 18 over X. Hopefully you've seen it. I don't know if I really explained enough here. Okay, so cross multiply, I get 3X equals 18 times by 4. Well, 18 times by 4, we can do that in a calculator. We can do that in our heads maybe. 72. Okay, divide both sides by 3. And yeah, what, 3 goes into 60 20 times is how I do it. And then it goes into 12 4 times, so it would be 24, right? Did I do that right? Yeah, 24. Okay, x equals 24 here. So 24 is going to be what AT is. Okay, what AT is here. So it's 24. Oops, let me do this here. And I'm not doing this question fast enough now because maybe you see it and hopefully you can move on with your merry way. But that's 24 is going to be AT. So let me go and fill that in. All right, I got 24. So question, right? If this is 24 and that's 18, what's that? Oh, it's 6. Okay, it's 6. Go ahead and put that in, right? Segment addition postulate. 18 plus 6 equals 24. Part plus part equals whole over there. Okay, so I have that. This is a 3 to 4 ratio. That's in a 3 to 4 ratio. This is in a 1 to 3 ratio. That's in a 1 to 4 ratio, okay? We know that over here, okay, this would be in a, well, I could make this 3y to 1y, right? Look at here. This is in a 3 to 1 ratio over here. Okay, so I know that, but do I know anything about this, right? This would technically be in a 4y, okay? 4y in length here, okay? Do I know what any of these lengths are over here? No, I don't, okay? No, I don't. So you need to know at least what one of the pieces are on for things that correspond to one another. You need to know at least this trapezoid side, as we did up here, or the side of the triangle, or the whole side here to fill out a side. Okay, if we don't know any of these here, then we're not going to be able to deduce what exactly AN is, NP is. We just know that it's in that 3 to 1 ratio here, or 3 to 4 ratio. We're talking AN to AP here. Okay, so I'm going to go NA on those here. So that's probably why I got those questions, because the person was probably wondering, hey, why am I getting an answer to this? I feel like I'm missing something here. And, I hopefully I explained that okay here. Let's contrast that with number 16, because I think number 16, you can get all of the answers to this one here. So perhaps let's take a look at this here. First of all, AT, that's the easy one. What's AT? Well, it's just going to be segment addition postulate. Part plus part equals whole. R is between points A and T. They're collinear. So we just add distance AR to RT, which should be 6 plus 4. That's 10. So that's easy. AT is 10. Okay, AN is 9. What's this going to be down here? Well, maybe let's get to that a bit later. Let's think about this. What's our scale factor? Scale factor is 6 to 10. So that means that, right, I'm going to set up a 3 to 5 ratio, and this is going to be in a 9 to, here, I'm trying to define variables and stuff like that and whatnot here. I was trying to, I guess my explanation was too complicated in this one here. But anyways, where am I getting at this one here? Let's do this here. 9 to x, the same as 3 to 5. Okay, right? Part to part equals part to part. Or you know what? I could have used the basic proportionality theorem this one, actually. Let's see. That's probably why this person didn't ask this question. So I know that this is 10. Okay, that's easy. Basic proportionality theorem, just straight up, right? I can remember that this over this equals that over that, right? This R and N divide segment AT and AP proportionally, right? Divide them proportionally. Ergo, 6 over 4 equals 9 over NP, okay? And that's probably how I do that one in that one here. I mean, I could have, yeah, other ways I could do it too. The book tries to show you there's more ways, one way you can do something. 9 times 4 is 36. NP times 6 is 6 NP. Divide both sides by 6, we get NP equaling 6. So there we go. We got 6 there, and that checks out here. This is in a 3 to 2 ratio. Here, 9 over 6, that's in a 3 to 2 ratio. Divide both of them by 3. What do you get? You get 3 here, you get 2 there. We'll divide both of these by 2. You get 3 here, you get 2 there. 3 to 2 ratio. 3 to 5 ratio there. Okay, so now we're going to talk in here. Let's see if we can just kind of figure this one out. 3 to 5 ratio here. So if this is 3, it's got to be 15, right? But also 9 plus 6. Oh, easy enough. Done and done. 9 plus 6, 15. And there we go. We have it right there. Okay, so let's go ahead and fill in our answers. We don't have that guy yet. We'll maybe get to that at the end here. So, well, TP is 15. Oh, then they gave us that earlier here. Hey, this is actually isosceles. Check it out here. Boop, boop. At least that in this instance, it's isosceles. Not going to be isosceles in all of them, but I don't think at least. So AP is 15. NP is 6. We deduced that from over here. AN, so I got it all filled in. Then the next thing is RN here. Okay, RN. Can't really use the basic proportionality theorem this one because RN has nothing to do. Points R and N divide AT and AP proportionally, but RN is just simply the corresponding side of a similar triangle from here to here. Okay, what do we know about the scale factor again? The scale factor is in a 3 to 5 ratio, right? 3 to 5 ratio. If we're going from, again, the ratio I set up, small triangle to large triangle, okay? 6 to 10. Okay, 6 to 10, or 3 to 5. I want to use 6 to 10 for this one. Small to large is the same as small. Okay, my small triangle, Rn, corresponds to TP in my larger triangle. But TP, I don't need to write TP. I don't need to write 15 because we know the length of TP. That's given to us. It's 15. Cross multiply, 6 times 15 is 90. 10 times Rn is 10 Rn. So 90 divided by 10 is what? 9. Okay, so we get Rn equals 9. And we're good to go there. All right, so that person got that one, but I figured I'd show that to you. That's some of your answers here in problem 16 to 21. You're going to get everything. It's going to fill in through. But here, the reason why this worked out is because we were given this, we were given this, we were given this. We were given something on both sides, and we were able to figure out the scale factor somehow, okay? Here, we're only given on one side. Nothing on that side, not going to get an answer on that side here. Here, we're given only something on this side, 2 things on that side. It's enough to figure out the scale factor. That's helpful. It really wasn't helpful for this one, but definitely nothing on that side because we have no idea what's going on there on the left. Okay. All right. Best of luck on the rest of the problem set. Hopefully you watched this video if you were stumped in this one. You can always email me any questions if you have them. Happy to make more videos like this to make available to you. Take care, guys. Enjoy the rest of it. I'll see you Monday. Bye.